Q10 part 1, we've the integration of ln 2x dx. I'm going to stick a 1 in here. So we're going to let u equal ln 2x du dx is equal to, still equal to 1 over x, even though it's ln 2x, so du is equal to 1 over x dx. Then we have dv is equal to the 1. So if we integrate dv, we get v, and the integration of 1 gives just x. So v is equal to x. So my solution uv minus the integral of v du is going to be equal to u, which we said was ln 2x, times v, which is x, minus the integral of x times the u, which is 1 over x dx. So the x's cancel to give a 1, so we have x ln 2x minus the integral of 1 dx, which becomes x ln 2x minus x. And don't forget, like I always do, your c. So this is part 1. Part 2. So number 2, let's let u equal to ln 2x. LATE is our acronym, so exponential, these are last, or exponents. U is equal to ln 2x du dx is equal to 1 over x. Du is equal to 1 over x dx. And dv is equal to x to the power of n. And if we integrate dv, we get v. And integrating x to the power of n, well, we don't know what n is here, but it increases the power by 1 and divides by the new power. So this is going to be x to the power of increase the power by 1, and the new power is now n plus 1. So this is v. So my solution to uv minus the integral of v du becomes u is, what did we say u was? ln 2x times v, which is, I'll give it a bracket, x to the power of n plus 1 over n plus 1 minus the integral of v, which is x to the power of n plus 1 over n plus 1 times du, which we now have to be 1 over x dx. So how does this tidy up? We're going to have ln 2x by x to the power of n plus 1 over n plus 1. It's obviously going to be in terms of n, minus, well, let's simplify this first. This is x to the power of 1 on the bottom, so we bring it up. On top, we're just going to have x to the power of n over n plus 1 dx. So we need to now integrate x to the power of n over n plus 1, which will become x increase the power by 1, divide by the new power. Well, there's already an n plus 1 on the bottom, so it's going to be n plus 1 by n plus 1. So it looks like we have the natural log of 2x by x to the power of n plus 1 over n plus 1 minus x to the power of n plus 1 over n plus 1 to be squared. If you wanted to tidy this up a bit further, we could factor out x to the power of n plus 1 over n plus 1 to be squared. That would mean we'd have to multiply that by ln 2x, which would mean we'd have an extra n plus 1 on the bottom times n plus 1 would cancel it. And then we factored out the whole of the second expression, we'll be factoring out 1. So I think this is a nice solution without forgetting your c, which I do at least 50% of the time.